Okay. My name is Subhanallah, and I'm also from Afghanistan. And I'll be talking about unsupervised image captioning, which is a paper published in CVPR 2019, also available on IEEE Explore. In today's presentation, I will cover these points. First, I'll talk about the introduction and background, and then we'll come to the problem statement. And next, we'll talk shortly about the proposed solution, and we'll discuss the contributions, and finally, we'll conclude the presentation. Introduction and background. First of all, we'll talk about image captioning, which is a task of describing the contents of an image in natural language.
Excuse me, Subhan?
Yes?
Slides are not moving. Slides are stuck.
Is it visible now, sir?
Yeah, yes.
Okay. So image captioning is actually the task of describing the contents of an image in natural language. And we can say that image captioning is presenting in natural language the objects and images in the form of sentences. So it can be used for as an aid for visually impaired people who cannot see well or who cannot see completely. This has applications as an aid for visually impaired people, and also skin vision it actually determines or says if a certain skin condition is cancer or not. It's also used, image captioning is used in Google Photos as well to classify photos into different categories. And Facebook uses this image captioning to detect faces or describe what there is in the photo. For example, identify objects that are on roads to distinguish objects that can pose danger. It can be used in robotics and so on in many places. So this is a problem of computer vision and natural language processing. First, we train the computer to see an image, and after seeing it, natural language processing techniques are used in the previous works. For the computer vision problem, they use the recurrent neural, the convolutional neural network. And for the natural language processing, mostly they use recurrent neural network. So some previous works which are based on supervised learning methods are here. I mentioned some of them here. In figure A, we see image paired captions. So images are collected and they are manually given captions. And this is used as a data set for training the model. So this is a supervised learning problem. And it is tackled in a supervised manner. And picture B, which is proposed, this technique is proposed by Hendricks et al. It is used to generate captions for novel objects, which are not present in paired image caption training data, but it uses certain captions for images, and then for new objects, it uses the visual concept to detect new objects. And C, in figure C, this is another study which takes the previous knowledge from a supervised learning. It takes the knowledge to a new domain and then train the new models using unsupervised learning with the knowledge previously received from the supervised learning. In D, as we see, images are described in Chinese language first in a supervised manner, and then Chinese language captions are translated into English in an unsupervised manner. In E, we see that Chen et al. Proposed a semi-supervised framework for image captioning, which uses an external text corpus, as we see here. And this is used to pre-train the image captioning model. So although these models or methods have achieved improved results, a certain amount of paired image sentence data is unavoidable. We should use some image paired sentence data. So we should have images with captions. So this F1, if we look at the F, this is the proposed method in this paper, where there are images, a separate data set of images and a visual concept detector and a corpus. The images are not related to the corpus, or they are not manually labeled. So we just get a set of images and a corpus of sentences describing images and a visual concept detector. So this is the proposed model shortly displayed here. So coming to the problem statement, image captioning models are trained in a supervised learning manner, which are based on image sentence pairs, which is a labor-intensive and expensive task. It is true that when we want to train a model, an image captioning model, we need paired image sentence data, and giving captions manually is difficult, and it takes a lot of work, and it's very expensive. And also the available data set, which is Microsoft Cocoa, this is a smaller data set, and it has less than or about 200,000 photos, which can pose many problems while detecting new objects, because there are many objects in the wild, for example. So the model may come across a new picture or object that it may not be able to caption it properly. So therefore, we need to relieve the dependency on the paired image captioning datasets. So this is the problem statement. And to tackle these problems, they proposed unsupervised image captioning, which they claim is the first attempt. And before this, there were supervised image captioning models only. So, and this relies on a set of images, a set of sentences, and an existing visual concept detector. And it is different from the supervised image captioning techniques because they only use image. Most of them use an image with a paired caption, but this one uses images separately, and they use an existing visual concept detector to detect what's in the image, and they use a set of sentences, or the sentences data set, which is separate. The image captioning model contains, it's actually made from the encoder and a sentence generator and a sentence discriminator. So this is the architecture of the unsupervised image captioning model, which is proposed in the paper, as we see here. So a CNN actually encodes a given image into a feature representation, as we see. And it is based on which the generator outputs a sentence to describe the image. The discriminator is used to distinguish whether a caption is generated by the model or from the sentence corpus. And the concept, once this is determined, the generator and discriminator are coupled in a different order to perform image and sentence reconstructions. And the adversarial reward, which is a reward, and also the image reconstruction reward are jointly introduced to train the generator via the policy gradient. And meanwhile, the generator is also updated by gradient descent to minimize the sentence reconstruction loss. So the generator is the sentence generator is based on LSTM. It uses LSTM, and the discriminator also uses LSTM. And for the discriminator, the parameters are updated by the adversarial loss and image reconstruction via the gradient descent. So we'll shortly describe what are mentioned here, the basic architecture. So the encoder, it contains one image CNN or convolutional neural network. It encodes the input image into feature representation, as we see here. And there are some common image encoders like Inception, ResNet version 2 and ResNet 50 that can be used here. But in this paper, they have used Inception version 4 as the encoder. And for the generator, the LSTM is acting as a generator, which decodes the obtained image representation into a natural sentence. As we see, the image representation. So this is the LSTM, and if it's seen there, it represents, like it says, a girl. It detected an object. So this is a natural language representation of the object detected. Okay. So the generator, this is the math that is needed, or the formula, where FC is the fully connected layer of the CNN, and N is the length of the generated sentence, and W denotes the word embedding matrix, and XT is the LSTM input, and ST is the vector representation of the generated word, and HTG is it's actually the hidden state of the LSTM, and final PT, which is the probability over dictionary at the tth time step, respectively. So after the generator, we come to the discriminator, which is also implemented as LSTM. So the discriminator tries to talk about, or to distinguish the difference, whether a partial sentence is a real sentence from the corpus or is generated by the model. So once the sentence is generated by the model, the discriminator checks it if it comes from the corpus or it is generated by the model. And here, this is the LSTM, where HTD is the hidden state of the LSTM, and QT indicates the probability that the generated partial sentence is regarded as real as by the discriminator, if it's real or not. So this was the basic elements of the model, the generator, discriminator, and the encoder. And after this, in training, as we don't have a lot of time, so these are the steps in training: adversarial caption generation, and visual concept distillation. In the adversarial caption generation, the generator takes the image feature as input and generates one sentence conditioned on the image feature. And then the discriminator distinguishes whether a sentence is generated by the model or is a real sentence from the corpus. The generator also tries to fool the discriminator by generating sentences as real as possible. And for this, the adversarial reward is used. And the reward value is used to check if this is giving the correct results or without loss. And the visual concept distillation. So this is used to distill the knowledge from an existing visual concept detector into the image captioning model. Specifically, when the image captioning model generates a word whose corresponding visual concept is detected in the input image, they give a reward, or it gives a reward to the generated word. And such a reward is called the concept reward. And also, the reward value is indicated by the confidence score of that visual concept to see if how much the concept distillation or this visual concept distillation or the knowledge gives the correct information about the object, whether it's reliable or not. And then the bidirectional image sentence reconstruction. Image reconstruction first. The image is reconstructed using the text which is generated by the generator. So a caption is used to generate the image or to reconstruct the image to see if it's correctly captioned or not. And the sentence reconstruction. This is the next step in in the bidirectional image sentence reconstruction. So the generator can reconstruct the sentence based on the obtained representation. Such a sentence reconstruction process could also be viewed as a sentence denoising autoencoder. And finally, these three objectives, when those three objectives are jointly considered, for the generator, the word sampling operation is not differentiable. We train the generator using a policy gradient, which estimates the gradients with respect to trainable parameters given the joint reward. So based on that reward, the model, the state or the discriminator is, the generator is updated or upgraded. We'll come to the contributions. So in this paper, they had the first attempt to conduct unsupervised image captioning without relying on any labeled image sentence pairs. And those three objectives were proposed, unlike other research papers previously: the encoder, sentence generator, and sentence discriminator. Which encoder encodes the image, and the sentence generator generates a sentence, and the sentence discriminator checks if the sentence is from the corpus or is generated by the model. And gradient descent is used to minimize the loss of the captions generated to see if they're correct or not. And they also proposed a novel model initialization pipeline exploiting unlabeled data. So the data is unlabeled, and the visual concept detector is used to detect the objects, and they are then captioned by the sentence generator. And also, they crawled a large-scale image description corpus with over 2 million sentences from the web for the unsupervised image captioning task. And they crawled the description corpus from Shutterstock, which is freely available, and the descriptions were taken from there. So it was the first attempt to make unsupervised image captioning possible. And this, to achieve this goal, the researchers presented three training objectives, in which number one was the generated captions are indistinguishable from sentences in the corpus, which they did successfully. And the image captioning model conveys the object information in the image. And the third one is the image and sentence features are aligned in the common latent space. And perform bidirectional reconstruction from each other. So once a caption is generated, it is checked. For example, a caption is generated, and then they generate an image back from the caption to see if it's reliable or not. And the Shutterstock website was used to take those sentence captions to crawl from them. So thank you. This was my presentation. Can you hear me?
Yes. Okay. Very good, Subhan. It's an excellent presentation. Anybody have questions?
Thank you, sir.
Okay, Subhan, I'm just a bit curious about the training process. They have proposed a model that can generate captions from images, and the model is trained from a data set where images and captions are not aligned. Am I right?
That's right.
Okay. And in their training process, they are using bidirectional image sentence reconstruction, which means that they provide image to the model, and model generates some sentence, and from the sentence they are again generating the images. So there's a kind of a cycle going on. I'm just curious that how they are enforcing that. I mean, we give an image to all they are enforcing is that the sentences must be close to the real sentences.
Yeah.
So it's possible that a model, on giving an image, a model can generate any random sentence, and from that random sentence it creates again that image. How they are enforcing that the sentence must be relevant to the relevant to the image.
Yeah, sir. We know with this training in concept reward, the captioning quality would be determined by the visual concept detector because it is the only bridge between the images and sentences. And the existing visual concept detectors can only reliably detect a limited number of object concepts. And the image captioning model should understand more semantic concepts of the image for a better generalization ability. And in order to achieve this, they propose to project the images and sentences into a common space such that they can be used to reconstruct each other. And the generated caption would be semantically consistent with the image in that way.
Okay, have they used some pre-trained models for image from image object recognition, or from and similarly from a given object to image generation? I just have they used some trained model? Because if they have used some trained model, the trained model is trained already to map semantics to the image, and vice versa, or they have trained just from the scratch.
Sir, they only used the visual concept distillation process, in which they use the knowledge from an existing visual concept detector into the image captioning. That they have not used any other model. This is completely unsupervised training. So there is still the knowledge from an existing visual concept detector into the image captioning model. Specifically, when the image captioning model generates a word whose corresponding visual concept is detected in the input image, then a reward is to the generated word is given. And using these rewards, the image the models are trained.
Okay. Okay, thank you. And please, if you can share that paper with me.